For years, astronomers have been closely monitoring one of the brightest and most enigmatic stars in our night sky, Betelgeuse, a red supergiant teetering on the edge of destruction. Experts long believed its demise was approaching, though they couldn't predict exactly when. Now, the James Webb Space Telescope has captured something previously thought to be nearly impossible, the very moment Betelgeuse began to explode. This is not just another observation of distant space. This is a rare, historic moment, the closest supernova ever recorded by humanity, a spectacle that changes our understanding of stellar death and the violent, beautiful chaos of the cosmos. Betelgeuse, situated on the shoulder of the Orion constellation, is no ordinary star. It's a red supergiant, more than 700 times the size of our Sun, and roughly 20 times as massive. Scientists have known for decades that this star was unstable. It would swell and dim, then erupt with bursts of energy. In 2019, it dimmed dramatically, sparking global speculation. Had the moment arrived? Was Betelgeuse finally going supernova? Now, thanks to the extraordinary precision of the James Webb Space Telescope, the mystery has deepened and evolved. For the first time, we are witnessing the active collapse of a star in real time. Massive surges of energy, erratic surface movements, and magnetic fields in disarray. Betelgeuse isn't simply dying, it is undergoing a spectacular transformation before our eyes. The James Webb Telescope has focused its infrared instruments on Betelgeuse for months, peering into layers of the star that no other observatory has ever seen. The data now coming in is nothing short of astonishing. Convective bubbles the size of Jupiter are bursting on the surface. Streams of hot gas are being ejected into space at unimaginable speeds. Hidden within the spectrum of light, scientists have identified a shockwave rippling through the star's outer layers, a clear sign of collapse underway. For the first time in human history, astronomers are directly observing the actual physics of a supernova as it happens. This isn't a computer model or a projection. It's the raw, real-time anatomy of a star tearing itself apart, and it's happening a mere 642 light-years from Earth. Unlike other supernovae that blaze in galaxies millions of light-years away, Betelgeuse is cosmically close. When it reaches its peak, the explosion could shine brighter than the full moon, even during daylight. But beyond its dramatic visibility, its proximity offers something far more valuable: a unique opportunity to study the end of a star's life with unmatched clarity. We'll be able to trace how its core collapses, how vital elements like carbon and oxygen are formed, and how shock waves reshape the space around them. What Webb has captured isn't just a violent death. It's the very mechanism that creates the ingredients for life. We are witnessing the reverse unfolding of our cosmic ancestry. This event goes far beyond awe and wonder. It unlocks a deeper understanding of how galaxies form, how planetary systems emerge, and how life, in its most elemental form, becomes possible. With Webb's capabilities, scientists can now simulate the final stages of stellar evolution with more accuracy than ever. We might even learn to predict which stars will go supernova next, decades or even centuries in advance. This isn't just progress in astrophysics. It's a profound moment of revelation, where humanity looks into the ancient abyss of time and watches light bloom from death. The explosion itself is sending waves across space, shock waves that ripple through the interstellar medium. Webb has already detected the early signatures of this: energetic particles moving outward, heating nearby gas clouds, and altering the structure of the star's surrounding dust halo. But perhaps even more significant is the possibility of a gravitational impact. From over 600 light-years away, Betelgeuse's core collapse may have emitted gravitational waves, the same type we've only recently learned to detect. If confirmed, This would be the first time a visible supernova has been directly tied to gravitational data, fundamentally changing our understanding of how light, matter, and space-time interact. As Betelgeuse falls apart, it raises a major question. What remains after the collapse? Could it become a neutron star, a black hole, or something entirely new? Webb's data indicates that the collapse might not be uniform. There are disrupted magnetic fields, pockets of plasma that seem to vanish, and material falling back toward the star, rather than escaping. Some scientists are proposing a new idea, a transitional object between a neutron star and black hole. It's something only theorized until now. If this proves true, Webb has provided the first observational evidence of a brand new category of cosmic object. Naturally, many are wondering, could this explosion pose a threat to Earth? The simple answer is no. Betelgeuse is too far away to cause direct harm. But the full answer is more nuanced. The explosion will emit high-energy particles, gamma radiation, and an expanding electromagnetic pulse. While it won't affect life, on Earth it could interact with cosmic dust clouds, alter the behavior of nearby star systems, and shift how we perceive light from other parts of space. Webb is already monitoring the spread and intensity of this radiation, as it may change the way we observe and interpret the universe for years to come. Betelgeuse is ancient, massive, and mighty, but like all things, it has a lifespan. What Webb has documented is not just the death of a star. It's a mirror, reflecting the inescapable truth that everything, even the brightest lights in the sky, has an ending. And yet, this isn't pure destruction. It's cosmic renewal. In its final moments, Betelgeuse is giving birth to new elements, new matter, and possibly even new stars. In the wake of this chaos, new worlds may one day emerge. We've been fortunate enough to witness this rebirth as it happens. Among the incredible details captured by Webb was something entirely unexpected: variations in the star's elemental makeup. The explosion isn't just releasing common stellar materials like carbon, oxygen, or iron. It's expelling rare elements such as technetium and yttrium, which can only form under extreme conditions. These findings are more than scientific curiosity. They allow researchers to trace the journey of matter across the galaxy, from the hearts of dying stars to the dust that forms planets, and ultimately to the atoms within us. Betelgeuse isn't merely exploding. It's revealing the blueprint for how life becomes possible. This star will never shine in Orion again. Its place in the night sky will become a glowing cloud of gas and debris. But its end is not a loss. It's a legacy, a gift of knowledge, matter, and insight. A reminder that even our own sun will one day share this fate. The brightest stars have their curtain call, but from that exit, something greater arises. Without supernova, there would be no planets, no oceans, no life. And thanks to the James Webb Space Telescope, we've now witnessed that process in full. The fiery fall of a giant and the cold, elemental rebirth of creation itself. Some 642 light-years from Earth, a star has ended not with a whisper, but with a brilliant roar that traveled through the darkness of space to reach us. And this time, we didn't just see it. We understood it. From the initial collapse to the detonation that followed, the event was no longer legend or theory. It was real. Betelgeuse didn't die in vain. It gave us answers to questions older than human memory. Where do elements come from? How do stars live and die? What will become of our own sun? In its final red glow, Webb captured more than a supernova. It recorded the beginning of our own story. And perhaps a glimpse of what comes next. So now we look to the skies and wonder, what else is the universe ready to reveal? And are we ready to witness it?